My Microbiota and I. From the moment we are born, and maybe even before that, every human is populated with microorganisms called microbiota. About 90% of the human body is made up of non-human microbial cells that are extremely specific to each person. While there are common trends in the population of microbiota between individuals, the population of microbiota is completely unique from person to person. The initial development of human microbiota begins from the moment you are born. In fact, everything from the way in which you came into the world, the antibiotics taken by your mother after birth, and even the external bacteria on the people who handle you as an infant can affect your unique microbiota population. Although you may connect the word bacteria with being harmful to the body, our natural bacteria, microbiota, largely enable us to fight off invading bacteria. The specificity and large quantity of human microbiota make it difficult to characterize each microbe in the human body. However, it's well established that microbiota play a large, beneficial role in the human metabolic and immune response. In the human gut alone, there are around 40,000 microbial cells. The population of microbiota in the gut has even been described as an additional organ of the digestive system, based off not only its sheer quantity, but also the huge impact it has on metabolism. Normal microbiota in the large intestine aid in the breakdown of food into biocompatible molecules that can be easily absorbed. This includes the breakdown of fat molecules to supply our bodies with energy. Our microbiota is subject to evolution over time. If these evolutionary changes drastically change the microbiota population, physiological changes can also occur. Disruption in microbiota is called dysbiosis and can be linked to immunodeficiency, diabetes, obesity, malnutrition, allergies, and even depression. While the development of a healthy digestive system is crucial from birth, perhaps more important is the development of a healthy immune system. Natural microbiota not only help develop and sustain the immune system, but in a mutualistic relationship, the immune system cells also work to sustain microbiota. Microbiota can combat invading pathogens by mounting attacks from many areas of the body. In fact, the microbiota living on skin, throughout the respiratory system, in the nose, throat, and lungs, and in the GI tract can contribute to combating foreign bacteria. In order to do this, microbiota must create an unfriendly environment for any invaders. Called environmental control, these mechanisms include microbiota outcompeting invaders for bacterial space and even secreting toxic proteins to kill disease-causing bacteria called pathogens. The relationship humans have with their gut microbiota becomes more complex and more interesting each time we look into it. Recent studies in metabolic diseases like obesity and diabetes have been shown to involve even more microbes than we initially thought. John March and this team from Cornell University in Ithaca studied the ability of gut microbes to lower blood glucose levels, which could completely change the way we treat diabetes in humans. March and his team took Lactobacillus gasseri, which is a common probiotic in yogurt, and added a human gene, glucagon-like peptide 1, to it. The study discovered that the altered bacterial cells started producing insulin. This allowed the rats to decrease their blood glucose levels to normal levels. After 3 months, the rats who had received this treatment were able to control their blood sugar levels at the same rate as rats without diabetes. March's aim is to produce a pill containing the bacteria, which could be taken daily to regulate blood glucose levels in diabetic patients. The bacteria in your gut can have a variety of effects on your weight. One study done by Washington University found that obese mice began to lose weight after consuming the feces from lean mice, and it's not because they didn't find the menu very appetizing. The lean bacteria in the feces from the lean mice colonized the guts of the obese mice, displacing their own microbiota. The entire community needs to be transferred, though. Only moving some of the bacteria had no effect on the obese mice. We need to be careful about what kinds of bacteria we ingest. Some strains of gut bacteria can actually promote obesity. a study published in Obesity Journal concluded that the specific strains of bacteria can promote inflammation, which can reduce insulin sensitivity. As a result, an increase in body weight may occur. A microbiota densely populated with obesogenic bacteria can lead to excessive weight gain. Through ingesting probiotics, live bacteria, we can manipulate the populations of our gut, although another supplement called a prebiotic can have drastic changes too. Prebiotics are food for your microbes, and so eating a balanced diet with fiber can aid in great microbial growth. On the other hand, eating a westernized diet full of caloric, dense foods can increase the population of obesogenic bacteria, like firmicutes, and decrease the population of bacteria that increase metabolism, and this leads to weight gain. Other human microbial interactions aren't so simple. Some so-called good bacteria can contribute to inflammatory bowel diseases, IBDs, such as Crohn's disease or colitis. Although these are caused by problems with intestinal immunity, it has been suggested that microbiota play a large role in how this is expressed. In individuals suffering from IBDs, it is believed that the normal microbiota are constantly activating immune cells and causing constant intestinal injury. Microbes aren't just implicated in digestive allergies either. New studies by the Technical University of Munich have shown that a lack of intestinal bacteria may be related to anaphylactic reactions as well. This is the response in people with severe peanut allergies. In people suffering from food allergies, a protein called NOD2 was absent, creating a large amount of the immune system molecule immunoglobulin E, IgE, to be produced. The greater the amount of IgE produced, the greater the strength of the anaphylactic shock. Another study by the University of Chicago found that one class of bacteria in particular, Clostridia, may protect against food allergies. Researchers took germ-free mice as well as normal mice and exposed them both to allergens, in this case, peanuts. Germ-free mice were found to be more likely to develop a peanut allergy. Researchers then gave the germ-free mice some Clostridia to colonize their digestive tracts, and the severity of the mice's allergies decreased. Although there are other factors involved in food allergies, this is an exciting new avenue of research on how to cure the supposedly incurable. Our understanding of how microbes affect us is constantly growing, and it is even being suggested that microbes may play a role in our mental health. Several studies, including one performed by Dr. Benton and his colleagues at the University of Wales, Swansea, had healthy women drinking milk that had been fermented with different bacteria. Results varied with each bacteria. Milk containing Lactobacillus casei, the mood of the volunteers improved. When they were given milk containing Lactobacillus helveticus and B. longum, the volunteers had lower levels of cortisol, a stress hormone, which the study showed was beneficial against anxiety and depression. In another study, this lower cortisol contributed to better focus on tasks. That being said, not all bacteria help our mood. A study at the University of Copenhagen found that people with depression often had an imbalance of microbiota, with one species, Alistippe, present in higher concentrations in people without depression than people with. Wow, I have to get some of this bacteria. How do I do that? Well, restoration and maintenance of a healthy gut microbiome can be achieved through the use of probiotics, prebiotics, or a fecal microbial transplant called FMT. A probiotic is a food or a supplement which contains actual live microorganisms. Once eaten, the probiotic moves microbes from your stomach and into your lower intestine, where they will begin to grow and reproduce. The prebiotics ensure the good microbes populate your gut so they can help with digestion, immunity, and health, while also preventing the growth of unwanted microbes. You can incorporate prebiotics and probiotics into your diet by eating things like raw vegetables, fruits, yogurts, cheeses, and lots of natural grains. The FMT approach is similar to a blood donation and transfusion, since many bacterial infections can be passed this way. The fecal donor is reviewed for many risk factors, including infection with unwanted bacteria or viruses, history of disease suspected to be related to the gut microbiome, and whether they have eaten food which the recipient is allergic to. These parameters are important because all the microbes in their fecal sample will be passed to the recipient. There's no way to pick and choose among the thousands in the sample. The sample is then treated such that only the microbes remain, and all the other excretions are removed. The recipient is treated to reduce the amount of acidity within their GI tract and given retention drugs to give the microbes time to move into their new environment. An FMT can be given through dehydrated pills or through an enema. This allows for the healthy microbiota to repopulate the gut and outcompete the negative microbes for resources. This is the only way to treat serious infections like C. difficile, which is responsible for 14,000 deaths a year. Most bacteria aren't harmful. In fact, the human body is covered with an extremely diverse population of microbes that help us fight off pathogenic bacteria, digest our food, and train our immune system. A disruption in the composition of gut microbiota can lead to obesity, diabetes, allergies, and even depression. It's important to have the right kind of microbes in your gut. Some microbes can help us lose weight, while others lead to weight gain. Some might activate immune cells causing allergies, while others can enhance our mood. So it's crucial to establish a proper balance of microbes. This can be achieved via fecal microbial transplants or by ingesting prebiotics and probiotics.